Hello everyone. Good evening, good morning, or good afternoon wherever you are. It's a pleasure to see you again and to have us join our live stream. So for the ones who were with us last week, we were talking about the complex topic of caffeine in tea, and we decided to make 2, even 3 parts out of it because it's a very complex topic. And today we're going to make a quick summary of the discussion of last time, and then we're going to talk about 2 other very important parameters. So during the live stream, because today I've got a presentation, I'm not going to play too much with tea, you can still ask questions, but we will probably keep them for the end. And depending on their difficulty, we keep it for next time, or if they are quick answers, I will try to answer to them at the end. So don't hesitate to send your question, and we do our best to answer to them because we like it to be relaxed and interactive. So today we're going to talk about the part 2, but before that we have to greet our fantastic cameraman. So Kosan, that is most of the time behind the camera, but I like her also in the future to be in front of the camera. So maybe come and say hello so everybody can see that we work as a team. Yeah? Me with the technology is not so great, so I like to talk, and Kosan likes to play with the cameras and everything and with the lights. So what did we talk about last week? Last week we had the part 1. We talk about 3 parameters, and the first one, which was the cultivar. And as a summary of last time, what we noticed from the studies that I looked upon and I reviewed is that some of the cultivars, so the varieties that are obtained through breeding, and the 2 varieties, one is called Assamica and one is called Sinensis. Assamica, we find it more for red teas, in Indian teas, in Southeast Asia, and the Sinensis, we find it more in China and in Japan. So generally speaking, all the teas vary in caffeine in the leaf between 2 and 4%. And usually there is more in Assamica than there is in Sinensis. That's rule number 1 that we found. Then we looked at the manufacturing process. And that is a very complicated one because we see a lot on internet the information that white tea is the lowest in caffeine, then followed by green, then oolong, red, dark. Is that really like that? Not really, but there is a trick to it. And I will talk about it, why it's confusing and why sometimes it's like this, and most of the time in reality it's not. So it's not so clear within the same cultivar. What I got from experience from scientists is that I talked with Professor Nakamura the other day from the Shizuoka University, and they've got more than 30 years of the past research. And generally speaking, there is a bit more in red tea than in green tea, but it's not so significant. What we noticed as well is white teas can be very high in caffeine, and that is coming from the part of the leaf. What we said also is that the roasted green tea, because we cook them at very high temperature, we roast them at 180 degrees, and we can degrade the caffeine. So in that case, we change the properties, and because of the high temperature, we can reduce the amount of caffeine. Now, after talking with Professor Nakamura, is not always the case, because it depends on the material that we're using. If we're using the fresh leaves, then it will be high in caffeine, and we cannot roast it too fast, otherwise we burn everything. So it's a complex topic as well. But generally speaking, when we roast it, we can reduce the amount of caffeine. Then the part of the leaf, the tips are very rich in caffeine. And it happens that we use the tips for the best teas. They're used in the silver needle of some white teas. They are used when we handpick, and they are used for some matcha and for some yokuro. So this is what we can say. Lower leaves or stems are low in caffeine. So when we go for a bancha, or when we go for a cookie cha or a karigane, we are lower in caffeine. So that is what we said last time. Now there are two things that I didn't have time to talk about, and I need, because the scientists will tell me, Alex, you didn't do a proper job. But you know, time is important. So I try to be as accurate as possible, but there are two things I would like to specify. There are two types of measures that are made in the lab. The number one is the percentage of caffeine in the dry leaf. So what they do is they take the leaves, they grind it into powder, and then they extract it, and then they measure the total amount of caffeine. They use very strong solvents. When we drink the tea, we use water as a solvent. We don't use methanol, we don't use benzene. So, and then they analyze it in a high-performance liquid chromatography. So the condition of the lab and the real condition of drinking the tea are not the same. These methodologies are very good to compare the teas between themselves, because we need to have a strict protocol. But they still do not represent the reality in absolute values of what we absorb in our body or what we have in our cup of tea. So that's what I wanted to precise. So the first measurement are in the leaf. It's per milligram per gram or percentage of the leaf in weight. The other one that is more tricky and that is more relevant is the concentration of caffeine in a water solution when it's brewed. And most of the time it's expressed in milligram for 100 milliliters. Sorry for the ones who are in American system, because they're using Oz, you know, ounces, fluid ounces. So most of the time they express a cup of tea with 8 Oz, 236 milliliter. So 6 Oz, 177, 8 Oz, 236, which represent the normal cup of tea brewed in America. We don't drink it the same way here. When we drink it, I would say, not the proper way, but the way that is the best extracted and the best taste, we make normally 3 extractions or more. And we make it small volumes, many times steeping the same leaves. That is another topic, but it's important, and we will talk about it maybe later or in another video, because how to steep the tea is a very, very interesting topic too. But anyway, to be significant, we should always use the same method for the same experiment, but it's not the case. And we will see later that we don't brew the different type of teas in the same manner, otherwise they taste bad. So what we measure in the water solution, it's still not the caffeine that we get in the body, because most of the time they brew it for a long time with boiling water, many minutes. This is not the way we drink the tea, but this is to understand the analysis. So with that explained, we're going to talk now, we're getting into the topic back. So we talked about 1 to 3 last time. I want to talk about number 4 and number 5. Number 4, it's going more into physics, so physicochemics, about how to brew, its temperature, time. So how the components are going to leach into our water solution, into our cup of tea. Number 5, it's more biochemistry and health. So there are other studies. I will try to simplify it. And actually it's very interesting. This is what makes tea very beautiful and very unique. So I'm not a doctor. I understand science, but I will try to summarize the important points. And if somebody wants to get more in depth in the future, we can go more into several articles and try to summarize it for you. So this is the topic of how tea is extracted. So when I extract my tea, I use hot water and I use a certain temperature. Then I put my leaves in a recipient and I brew it for an amount of time. If I use very hot water, if I use cool water, that will get a different result. If I brew it for 30 seconds or if I brew it for 5 minutes, I will get a very different result. So what is important is the temperature of water. So the caffeine and the other compounds of the tea will come from the leaf into what we call the liqueur, the extracted liquid. And of course, it will depend on how many brews we are doing, because the first brew will not have the same amount of caffeine than the successive brews as well. So I found something that is very interesting. So as a rule of thumb, if we've got a high temperature, the caffeine will be quickly extracted at high temperature. The higher the temperature, so 100 degrees, the caffeine will leach very quickly into the solution. Now we can influence. It's not only true for caffeine, it's true for other compounds as well. So, I don't know why this one is moving alone. Anyway, maybe there is a ghost pressing the button. So, we've got this study that is very interesting that I found. So it was a Japanese study. This time at the end of my presentation, you will see all the links of the research, all the articles that I've used for that study. Everybody is mentioned. I don't forget anybody. So what we have here is they made experiment in cold brew using low temperature. On the left side, we've got a cold brew at 10 degree water. On the right graph, we've got a cold brew in ice water, 0.5 degree, which I'm doing from time to time as well. And what we noticed is roughly after many, 1 hour and here 24 hours, the amount of caffeine that is extracted in the cold brew is half the amount of caffeine that is extracted for 2 minutes at 80 degrees Celsius. That is very important because when we brew the tea in cold brew, we get half of the caffeine. And the caffeine in the tea is already not so huge compared with a coffee or with an energy drink. So that's point number one. Now, if we want to go even further, if we reduce the brewing temperature to ice, so ice brew, which I'm doing from time to time, then the level of caffeine is reduced by 80%. So 20% is extracted. This is extremely interesting. So here in our tea house, we brew the tea different ways. And we've got also ice brew and we've got also cold brew. It changes the flavor, and with some of the teas, it's very. We also reduce the amount of extraction of catechins, especially the EGCG, the epigallate catechin, that is very important as an antioxidant, but another one is going pretty well. On the other hand, the amino acids, like the L-Theanine, is leaching very quickly and very easily, even at low temperature. So if we want to have a relaxing tea, the best tea to have is the iced tea. Not the one you buy in the supermarket, the one you made in your bottle with ice or with cold water. So that's a very important point. High temperature, you will get a lot of caffeine. Low temperature, you will get a reduced amount of caffeine. So this is how we usually brew in a low temperature. Reduction as a summary, 50% 10 degrees brew or 50 degrees Fahrenheit for you, my friend in America, and 80% reduction in ice brew tea, 30 degrees Fahrenheit. And here I'm going to talk about another study about the number of brews and the caffeine that is extracted. So here, of course, we've got a lot of diagrams, but what was made in this study is different type of teas were extracted with successive brews. And as a rule of thumb, the number of milligram per cup was always higher in the first brew than in the second brew than in the third brew. So it's true that we extract more caffeine in the first brew than in the second and in the third. At the same time, their condition, look at this, because we have to go back in the real case. They use boiling water for 5 minutes and they made 3 brews. If we make, of course, these are mostly, here we are going, this one is a green tea, so it shouldn't be extracted with boiling water. The oolong tea can be extracted with close to boiling water, and the red or the black tea should be also extracted with boiling water. But 5 minutes is very long. So it's good for the experiment to compare, but in reality, if we have short brew of 1 minute, our proper tea is drunk, we will have lower concentration of caffeine in the brew second, brew two, and a bit higher in the second brew and a bit higher in the third brew. So this can change. So if we have a long brew with a high temperature, we get a lot of caffeine in the first sip, in the first brew, and less in the second or third. Keep in mind that can change is not always true. I know that with some Japanese green teas, we can get more caffeine in the second brew than in the first brew. So keep this one with a lot of caution. Now, I like to talk about what we read very often, and that is a myth that is not true, and I like to explain why.
Before this, we
Yes.
have a new question.
So let's see if the question is coming and if we can answer to it right now. Let's make a little break.
Okay. So the question is, does this mean that if you brew tea cold, no caffeine is released?
Okay, I repeat the question because I've got the mic today and I'm not sure that you heard the question. So the question was that if we brew the tea cold, is no caffeine released? That is not what I said. I said that a lot less caffeine is released. So in 10 degrees, so if we put the bottle in the fridge, we will reduce the caffeine amount by 50%. We will have half of the caffeine. And if we brew with ice, we will have 20%. So 1/5 in that case, and 1/2 with cold water. But we will still have a bit of caffeine released. Now the amount of caffeine that you will release can be very low. Maybe it's not significant. So is it still good to give it to a kid? Well, I guess it will, in that case, I don't guess, I know, it will be lower than a glass of Coca-Cola. With the benefit that you will have some amino acids, and we will see later that amino acids are playing against the effect of caffeine. Let's go back. So, washing up the tea with hot water. Some people pretend or repeat that if you want to reduce your amount of caffeine, you wash up the tea with hot water. It's okay, it's already almost 20 minutes, but tonight we take a bit longer because we need to close that topic, and I would like to finish that chapter. So I won't be too long. We might have another 5 to 10 minutes. So can we wash up the caffeine with hot water? So it doesn't work. For the good reason that if you try to wash up the caffeine, you will need to brew your tea for more than 5 minutes and throw it away. And when you do that, after you wash it up, you don't have anything left or very little left. Your second brew or your third brew will be very poor in taste and in polyphenol, and you will lose completely the amino acid. So it defeats the purpose. That's the thing. You will need to wait for a long time. If you do it very, very quickly, you will not change pretty much the profile and you will not remove a lot of caffeine. So it doesn't work. If it will work, the companies will do that in order to remove the caffeine. Obviously, they can't. So I'm moving on. I have to talk about matcha. Why? So I'm going to go back because matcha is very specific. and I didn't talk about it last time. So matcha is a specific tea, and it is also rich in caffeine and is rich in amino acids and rich in theanine. So matcha is a super boost, for the good reason that the process of matcha is putting green tea into a powder, very thin powder. So I'm not going to talk about all the details, but basically we put all the leaf in a very fine powder. And then we brew the powder and we whisk it, and basically all the tea leaf, we don't get only the infusion, we get the full leaf. So the amount of tea that we ingest at that moment is very high. It can be 4 times the amount of steep tea, depending on how much powder we use. And of course, we drink the full leaf. That means that the amount of caffeine and the amount of the other compound is very strong. And what we get is an equivalent of an espresso. So we do it from time to time as well. It's beautiful, it's thick, but normally we don't drink so much. So you get the shot. You get a lot of caffeine, you get a lot of theanine, you get a lot of polyphenol, you get a lot of everything. So it's beautiful, but you try to drink less than if we drink a full cup of tea that is a bigger amount. So that is for matcha. If you have questions about matcha, we can make another session another time about it, because it's a very interesting topic. Now let's talk about factor number 5, and I will finish with the topic today, the caffeine absorption in our body. So how does it work, especially from tea? So tea, contrary to other compounds, has more than 200 of other chemical compounds, natural compounds, that are extracted in water. And one of these compounds that is very interesting, a family of compounds, is called the amino-acids. And the majority of this amino acid in the tea, adds something very particular, is the L-Theanine. And this L-Theanine is specific to tea. We don't have it in coffee, we don't have it in guarana, we don't have it in guayusa, we don't have it in mate. Naturally, we have it in tea, in Camellia sinensis. We don't have it in rooibos, and that is a beautiful compound because it acts as a relaxant, and it's an antagonist to caffeine. So let's talk a bit quickly about it. So exclusive to tea, the L-Theanine. So the molecule is very specific. It brews very quickly into the water. So as soon as we pour hot water or cold water, the theanine is released, and that is very interesting. So it has a very different biological activity. As a summary, I'm not going to go into the detail. There has been a lot of research made with theanine as a supplement or from tea. But what is beautiful about it, it neutralizes the caffeine and it works together with it. So the stimulant effect of caffeine is slowed down and is reduced by the effect of theanine. So the caffeine you get in a tea is not equal to a caffeine you get in an energy drink or that you get in a coffee. That's the first thing that you should be that we have to remember. And it has some neuroprotective effect. It acts on the glutamate receptors, and it acts on the GABA receptors. Both of them are relaxing, anti-stress. So what is very interesting, they made a study in 2013. So the oral intake causes feelings of relaxation and relieve psychosocial stress. So when I read into the detail, it means it was related to personal relationship with partners, friends, relatives, managers, employees. So if you don't want to be angry with your wife, then drink tea. If you cannot stand your manager at work, drink tea. It will help you. And make them drink tea as well. It will make them a better person. So now, which teas? That is very complex. I try to look at which kind of tea has more concentration of amino acids. And it is common belief that we have more amino acids and more theanine in green teas than in oolong teas or in red teas or black teas, like they call them. And it's tricky. I look at different studies, and what we can find is, yes, sometimes the amount is bigger in green teas, but not always. There are some cases where the amount of theanine in oolong teas actually can be high, but generally is a bit lower than in green teas. And what we found also is we have some cases in red teas where it's also very significant. So that is what we need to remember. You also have it in other type of teas. It's not only in green teas, but generally in green teas we will see that it's also significant. Here there is another study where they compare green and black teas, and look, or here the extracted 13 is quite significant, but here we've got a black tea that is 24. So there are some black teas that are high in theanine too. The thing is, we don't know exactly which ones, and we don't make an experiment or measurement all the time. So my feeling is that it depends on the quality of the tea, and it depends on the extraction. So if we try in lab conditions, we can get many non-relevant or non-workable. It's difficult to get some rules. But the theanine is present in tea, and I found something else that is interesting. Maybe that is more interesting. The special case of Japanese teas. So Japanese teas are two particularities that are not common in other type of teas. Number one, they are steamed, whereas the other ones are roasted or pan-fired. Does it influence? That's the first question. The number two is some of the Japanese teas are shaded. So gyokuro, matcha, kabusecha are shaded. And when we shade the tea, we change the tea profile, the composition. We increase the level of amino acids and theanine. And this is how we create that specific umami flavor that is rich in theanine. So the Japanese teas actually are rich in theanine, and that is an important factor, especially the gyokuro and the matcha. And that is a key factor that we need to remember. Now, another topic here that I looked at is what we call the ratio between caffeine and theanine. And when we've got a lot of caffeine and a very little of theanine, then the caffeine effect will be stronger. When the ratio between low caffeine and high theanine is met, then we've got the best effect for health, and we've got a stronger neutralization of caffeine. And there have been some studies looking at the different ratio between the amount of caffeine and the amount of theanine. And what we noticed is that some of the white teas, the ratio was pretty equal. Then we go, that is obtained from tea bags. So is it fair to go for tea bags? You know, tea bags is not the same tea like the good quality loose teas. We're going to talk about it as well. What makes the difference between what is sold to you in tea bags and what is sold in loose leaf, that you can see the quality is very different. But we can see a very high value here, 4 times. Okay, Piquin green melon. I will call that pretty crappy tea because we've got tea bag, 4 times difference. That's definitely the theanine level is pretty low and the ratio is very bad. Bancha, Japanese bancha, of course made with lower leaves and with a high temperature. The bancha typically has low amount of theanine. So I'm not surprised that the amount is pretty low in that case. Then we've got Alishan Oolong 345. The Oolong are not so rich in theanine, and they are stronger in caffeine in the ratio. And pu'er actually is off the chart because the pu'er have almost no theanine, post-fermented, and they have caffeine. Let's find another one that is balanced. We show in a green tea. I saw Vietnamese. Yes, Vietnamese and Mao Fen green tea, 158, 168. So the ratio is pretty balanced. These teas will have a lower absorption of caffeine in your body because the theanine will be stronger. And that is an important thing to look at. And finally, we showed that during one of our videos before, that was showing the amount of caffeine by leaf. One thing important, tea made from stems, like a cookie cha, you see the amount of theanine in the stem is super high. So the stem tea that is usually looked down is a very soft tea and is a tea that is poor in caffeine and rich in theanine. And that I really like to promote this type of tea because it's good for health. So with that, I'm going to end this presentation. I make a quick summary. So 1 second. So, as a summary, all the teas contain caffeine. So we need to be clear with that. All the tea from Camellia sinensis, variety sinensis assamica, all contain caffeine. The caffeine in the tea is affected by the cultivar. Sinensis are lower, assamica are higher. This is a rule of thumb. Then the process. But in the process we need to be very careful. The variation of the caffeine can be high and low. You know, matcha can be high, is a different process. Gyokuro can be high. White tea from the tips can be high. More important are the caffeine coming from the leaves. The top leaves, like the tips, are rich in caffeine. Lower leaves and the stems are poor in caffeine. Then comes the extraction. Very high temperature, extract a lot of caffeine quickly. Lower temperature, extract caffeine very slower and limit the amount of caffeine. The number of brew. I recommend to steep the tea in small quantities of water. Maybe high temperature is okay, but quick. And we get 2 or 3 brews, rather than having a brew that is too long and too strong. First of all, you will reduce your total amount of caffeine. And number 2, you will enjoy a better taste with your tea. It's not a coincidence why in China and in Japan, this is the way we brew tea, to extract the best of the taste and of the compounds. And finally, the absorption of the caffeine is influenced by the presence of other molecules. We talk about the amino-acids and the L-Theanine, specific to green tea and compensates the effect of caffeine. And the last thing that is specific to you and is more, biochemistry and biology and people, some people are more sensitive to caffeine than others. I can drink caffeine in the evening, I don't have a problem of sleeping. If Kosan is drinking a strong tea in the evening, she will have problems sleeping because she's sensitive to it. So people are not equal in their reaction to caffeine, depending on the amount. So with that, we gave you some rules, some basic keys to show you how to choose your tea. What are the factors that affect the caffeine in the tea? And next week, I'm not going to speak in front of a presentation. Next week, we're going to choose and to prepare together and to be more interactive. We will have more questions during that time. We're going to prepare 2 teas. I'm going to show you 2 teas that are strong in caffeine for the people who want to have their shot. And we will make 2 teas that are very low in caffeine for the people who want to be more relaxed. So now, like I promised, I'm going to scroll through. Here are my references, so you can see them. You can pause on your screen and you can look. You just type on Google, all of the article will come out. They're all being serious studies that are referenced and published in journals. So they have been peer-reviewed. They are all serious studies. It's not things that are just said on the internet, you know, because somebody pretended. All the serious studies always question it. Where is it coming from? In which condition? Who said that? Many of the commercial tea companies, they will put things, but they don't put any references or measurement or analysis. So I will question that. Me, I put my sources, my references. And here is the page number 2, because I use more than this. Another 5 references. And as you can see, there are studies that are made in the US, in Japan, in China, sometimes in South America, East Europe. So there is a strong interest in tea worldwide. So with that, I am very happy for this session. You know, it was a pleasure to talk about this topic with you. Sorry it was a bit longer than the last time, but with that we close the topic, and next week will be more relaxed. I don't know if we've got more questions, so if we got more questions. Do we have more questions that came, Kosan?
No, we are full.
We're good.
Yes.
So if you have more questions, please put your question on the Instagram or on the YouTube after our upload. And the next week we will take more questions on the go because we'll be more relaxed. The pace will be not so long. We will be talking together while having tea. We'll be a bit more interactive. So I hope you will find that extra interesting. Push the like button if you like it. And if you have any question, don't hesitate to reach us. And if you are in Japan, by all means, come to see us. We'll be happy to have a cup of tea with you and to talk about tea. With that, you know, we wish you a nice evening. And we will see you next week. Kosan, thank you very much for taking care of the video. Bye-bye, everyone. And see you next week. Thank you.